Dear ladies and gentlemen, I'm Herman Schneeweiss and I would like to present to you results of Inspire Hackathon challenge number 6, analysis of Sentinel-2 and Sentinel-1 time series for the purpose of agriculture. The main topic we've been working on is classification. Our main innovation was that we didn't use single date classification, but as an input, we used images from more dates, so-called multi-temporal time series classification. The main advantage when you use more images from different dates is that different land cover objects which seem similar at one date on a single date image and are almost impossible to distinguish by computer. However, when you use time series classification, the objects usually seems different on images from different dates, and it's much easier for algorithm to distinguish the objects and correctly classify them. We used less project infrastructure, so we have our satellite data stored on a Spark server, and as an input you can theoretically use how many images you want, but you also don't want to use cloudy images. And here you see our database of images for Africa. In Africa, we don't have much data, so we did only unsupervised classification. We did the classification on the borders of Uganda and Kenya near Victoria Lake. Yeah, somewhere here. I will switch to orthophoto, and you see that the classification makes sense, because the water is classified as water and forests are near forests comparing to the orthophoto. Also, when you zoom a bit in, you see that there are visible some roads and urban areas and some other forests. However, when you want to see details, it's very difficult in Africa because the objects in Africa are very small. The the houses are small and the fields are small. There are no big woods, but usually solitary trees. So yeah, that's the limitation of the classification small objects with satellite. Then we use the classification in Slovakia. We did the unsupervised classification, and you see the results are much better because the fields in Slovakia are much bigger. And we also did a supervised classification, because unsupervised classification tells you only there are some classes and they are different, but you don't get the information what does the class represent. You have to do supervised classification to see what does the class mean. And here you see the result. It's only some basic classification, only a few classes are classified. If you don't understand Czech, this means these three colors are fields. This green color is forest. Then you have urban areas, roads, railways, lakes, and rivers. So you can compare the results with orthophoto image, and uh, you you see we've used different algorithms to classify the images, and each algorithm is better for different purpose. So uh, so it depends what you want to do with the classification. Most detailed classification was done in Rostinice farm in Czech Republic, because we have most a lot of data from the farm. We've done also unsupervised or supervised classification. These layers are supervised classification. These layers, which has in name RVI, means it is from Sentinel-1. When the layer has name EVI, it means it is from Sentinel-2. But the best result gives layer when you compare the combine Sentinel-1 and Sentinel-2 satellite data. You see, you can quite well distinguish also the strips on the field, and we also when you do the classification, you need to somehow measure the accuracy of the classification. That's why we did some uh, accuracy measurement. These rows are all the classification we measured, and most interesting is this graph, because it shows the accuracy of classification based on combination of Sentinel-1 and Sentinel-2 data. And you see that when you use only data from 1 month, you get about 50% of accuracy. But when you add more months, when you use data from March, April, May, June, and July, then you get 95% of accuracy. So that's also the evidence that time series classification is much better than only single date classification. When we wanted somehow to visualize the accuracy, we used pie charts here. The color of in the field shows you which crop was actually in the field, and the color in the pie chart shows you uh, how the algorithm classified the pixels in the field. So, for example, when you have this field, then you see in field there was spring barley, and the algorithm classified 3/4 of the pixels as spring barley and 1/4 of the pixels as forage pea. You can also use this method of visualization, but basically it is the same. But I personally think that pie charts are better to understand. A different method is to say that the field was corn when most of the pixels were corn. So it doesn't say you how many of different classes were in the field, but it only says you how what's the majority of pixels classified. But it's quite easy and understandable way to to visualize the result of the classification. Another possibility what you can do with the classification is to make vectors from them, because it's when you don't have vector data of the fields, you don't you are not able to do many other analysis on the fields. And in Africa or in other countries, it's not so easy to get the vector data. So there is a possible way how to get the vector data of the field borders only from the satellite images, and the results are quite good. The second part of our group was dealing with topic of crop phenology, and we wanted to know what is the development of the index of particular crop in the season. So these graphs shows how the index develops through the season for winter wheat in this case, and we did it also for maize, and we compared the results with our results with some other results in literature. And this is also very useful when you want to identify the crop on the field and you don't have the crop data from the farmer. And last but not least, I would like to mention we have cooperated with different challenges. We cooperated with challenge number 1 because they used our classification results to develop their open land use database. Also, challenge number 2 used it for some clustering analysis. And we also provided our Earth observation and agriculture know-how to challenge number 8 to create the agroinfo application. I would also like to mention that all the maps we developed are available on different hubs. Maps in Africa are on Smart Afri Hub. Maps in Slovakia are on agrihub.sk, and maps from Czech Republic are available on agrihub.cz. And I hope you like our results. We really enjoyed the challenge, and we were also surprised with the useful and interesting results of our challenge, and we are looking forward to another Inspire Hackathon